Hello. So here is the first of multiple videos on weighted voting. I did decide to make each topic its own little video just so that you can more easily navigate the videos, and then they won't be so long and you can take them in chunks. All right, so I think we're going to start with a video just on sort of the introduction stuff, the weighted voting, and then we'll see how it goes from there. Okay, so weighted voting. So we're still talking about voting, right? But here we are talking about a system in which every vote has some weight attached to it, right? So kind of what we were talking about before, like, when people were voting, it was like everybody just had one vote, right? And then you were trying to count those votes and see how they would work. Here, we can give different voters different weights, right? So for example, oftentimes like with a company, the stockholders get like one vote per share, right? So someone who owns a lot of the stock has more votes. So they have more weight in the voting system, right? So what like their yes or no is going to be counted as more powerful than someone with fewer shares and votes. Okay. We're also going to talk in like how the power works out in these weighted voting systems. We'll have a whole section on power. We have interesting ways of defining power. All right, so let's do some vocabulary. So when we're talking about weighted voting, oftentimes we call the people that have the votes players. I guess it's just an easy way to talk about it. It kind of makes it sound like a game, right? But and I guess in a way it kind of is. But each individual or entity casting a vote is called a player. And if we're talking in generalities, we are notating those players by this notation here. So this is P sub 1, right, which we would probably say P1 because it's much easier than P sub 1. So P1 is representing player 1, right? P2 is representing player 2, and so forth. You'll see in a minute that in the weighted voting system itself, we don't use the P's, but we might want to refer to player 1, player 2, player 3, and having a way to do that in general is very nice. So that's how we would do that. All right, then each player is given a weight, right? So that's how much weight their vote gets. And we call the weights W's. So like W1, that would be weight 1, which is the weight for player 1. Right? So W1 is the weight for player 1, W2 is the weight for player 2, W3 is the weight for player 3, and so on, or Wn is the weight for player n. Now notice n is a general, we're saying we're talking in generalities. So however many players you have, say there are n of them, right? Then P sub n would be player n, and W sub n would be the weight of player n. So n just, when you have a specific voting system, n will have you'll have a certain number of voters. So n will be not n, but a number. Like maybe you have 10 voters in your system, then n is 10, right? So you'd have 10 weights, 10 players. Okay, so we got players, we got weights. So then there's quota. I feel this sentence here is confusing to me, but let's see if we can make it make sense. Quota. The quota is the minimum weight needed for the proposal to be approved. Okay, so the sentence is, the quota is the minimum weight needed for the votes or weight needed for the proposal to be approved. Okay, so like the minimum number of votes you need, that's the quota. And the quota is represented by the letter Q in general. So if we're talking in general, right, the quota, when we see Q, that means quota. And then we write a voting system like this. So I'm going to highlight this for you. So notice, I'm just going to point out the characteristics here. We've got the square brackets on the ends. That's just sort of, gathering everything together, letting our eyes see it. First, we list the quota, right? And then you put a colon to separate it. And then you list your weights separated by commas, right? So notice here that if we had a particular voting system, I don't know, let me make one up here. Say the quota is 5 and our weights are 4. No. How about, and our weights are 3. No, 3. How about 3, 2, 1. Let's do that. That's kind of what we're going to do down here, but I'm trying to make it so it doesn't violate any of the limits that we're going to talk about in a minute. So if this were a voting system, I could tell right away that there are 3 players, right? Because there are 3 weights listed. That means there are 3 players. Player 1 has 3 votes. Player 2 has 1 vote. Player 2 has 2 votes, and player 3. Oh my gosh, I'm confused with the numbers. So here is player 1. That's the weight 1. That's player 1's weight. So player 1 has 3 votes. Player 2 has 2 votes. And player 3 has 1 vote. Okay. And then the quota here is 5. Okay, so that's just an example. That's how that works, right? You would see the quota followed by a colon and then a list of numbers that represent the weights of the players in the voting system. Okay, so let's talk about some limits on the quota and why we might want to have limits. So the first limit is we want the quota to be more than half the total number of votes. And really what we're saying is we want there to have to be a majority for anything to pass, right? So we don't want to make a quota, but then have the yes and the no's have the same number of votes, right? We don't want it to be split, like if 50% of the voters say yes and 50% say no, right? We're talking like this is regardless of the weights right now. If half the people that have votes say no and half the people say yes, we kind of don't want that, right? Or we don't want there to be like a tie. I guess I just lied what I said, regardless of the weights, because we don't want there to be a tie in the number of votes cast, right? So I mean, half the people is not the point, but if half the votes are for yes and half the votes are for no, we really don't want that to happen. So you can avoid that as long as you make the quota more than half the total number of votes, right? So here's an example. If we look at what we mean here, here's a voting system where we have, you can see there are 3 players, right? Just like the one we talked about before. There are a total of 6 votes here, right? And half of 6 is 3. So right now the quota is set at exactly half the votes, right? But notice how what could happen here. Player 1 could vote yes, and then players, looks like an R, players 2 and 3 could vote no, and that would mean 3 votes for yes and 3 votes for no, right? And we don't really want that to happen. We don't want there to be the same number of votes for yes and no and still pass whatever the resolution or whatever decision is trying to be made, right? So as long as you just make the quota more than half the total number of votes, that will never happen. You'll never get a yes-no tie with the number of votes available. Okay, so we're good with that, which is why the quota just has to be more than 50% of the votes. Okay. What is the second limit here? I think it's the last one too. The quota can't be larger than the total number of votes. So this should be kind of obvious, right? Because if you have 6 votes, if you only have 6 votes altogether, right, and you make the quota 7, you never make the quota. And so that was like just ridiculous. There'd be no point to that, right? So if you only have 6 votes to give out, but you have to have 7, it's like if you do that, you've purposely made a system that will not work. Okay, so we definitely don't want that. So you have to make sure that the quota is not larger than the total number of votes, right? Which you would find by adding up all the different weights of the players, right? Because those weights are basically kind of like, you can think about number of votes. So player 1 has 3 votes, player 2 has 2 votes, player 3 has 1 vote. Together, those are 6. So the quota should not be 7, because then no matter if everybody votes yes, you still can't pass whatever resolution or make whatever decision you're trying to make. Okay, so keep those in mind as we do some examples. All right, consider the weighted voting system. So we've got this lovely weighted voting system here. And it's asking us some questions. How many players are there? What is the total number of votes, or the total weight of all the votes together? And then what is the quota in the system? Okay, so I think the easiest one to answer is part C, like what's the quota? Because we know that in a weighted voting system, we have a square bracket, then we have the quota. Okay, so clearly the quota is 47. So the quota is 47. So that means in order to pass, if this is a committee or something, or they're trying to pass, I don't know, laws, resolutions, proposals, whatever, 47 votes are required in order to pass whatever they're going to vote on. All right, well then how many players are there? Well, we just have to count the numbers after the quota, right? How many different players are there? They are, what's represented here are the votes of each player, but each player is included here. So we just have to count. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Since there are 9 weights listed, there are 9 players. Okay, so there are 9 players in this voting system, and they have various weights, right? So the total number of votes, the total weight of all the votes together, you just add up all the weights, right? So that's going to be 10 plus 9 plus 9 plus 5 plus 4 plus 4 plus 3 plus 2 plus 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. And just add those all up. So I would get a calculator. Hold on, I'm going to bring this over here. No, not full screen. Don't do it. 10 plus 9 plus 9. Oh, that's a 6. Don't do that. Plus 5 plus 4 plus 4. Plus 3 plus 2 plus 2. You could probably do this in your head, but that's 48. So if I didn't make any errors in my calculating, that's 48. I guess that makes sense, right? Okay, so there we go. So in this weighted voting system right here, we've got the quota is 47. There are 9 players, and there's a total of 48 votes. So this is interesting that in this particular system, it's all they're requiring almost unanimous, right? Almost unanimity, like 47 out of 48, not quite all, but almost, right? Almost everybody has to say yes in order for this to happen. Now, if you think about it, maybe everybody has to, because if you add up all of these up until the second to last player, that's 46 yeses. So even if they all said yes, if that last person said no, that would not meet the quota, right? So in essence, this actually, even though the quota is one less than the total number of votes, you still have to have a yes from everybody to meet that quota. You can't get to 47 without everybody saying yes. So just a note. Okay. So we've played with that. If we want to see, this would be, wait, oh no, I'm not going to do that. Never mind. Okay. Let's go to example 2. I'm going to scroll past what we just did. Consider the weighted voting system. So notice they give us a voting system. The quota is unspecified. So they just put a Q there. They're saying, we're going to ask you some questions about the quota, right? But we do know some stuff. We know that there are 1, 2, 3, 4, 5 players. We want to write that down. Hold on, there's a piece of paper in my way. Thank you. So we know there are 5 players. And we know that player 1 has 7 votes, player 2 has 5 votes, player 3 has 3 votes, so on and so forth, right? So what is the total number of votes? Let's see, that's going to be 7 plus 5 plus 3. I can't erase what's going on. 7 plus 5 plus 3 plus 1 plus 1. What is that? 12, 15, 17. That's 2, 5, 10, 17. Yeah, so just double check there. So total number of votes is 17. That's good to know, because if we're going to answer these questions, we have to know that. Because remember, the limits on the quota have to do with the number of votes, right? What were they? The first one was the quota needs to be more than half of the total votes, and you can't have a quota that's bigger than the total possible number of votes. All right, so the first question here is, what is the smallest value that the quota can take? Okay, so the quota has to be more than half the number of votes. So we need to find out what's half of 17. All right, half of 17 we can find by multiplying 1/2 by 17. So 1 divided by 2 times 17. Of course, you could have put 0.5 times 17 because 0.5 is a decimal. All right, so half of 17 is literally, right, 8.5. Now, we are counting votes here, so there's nobody can be offering half of a vote, right? And so we can't round down because 8 votes is less than half of 17. So we got to round up, right? So if we round up to 9 votes, then 9 votes is the smallest number that is more than half of 17. Okay, so the 9 votes is the smallest value the quota can take. Because if 9 out of 17 say yes, that's more than 50%, and that's good, right? All right, what is the largest value that the quota can take? Well, the total number of votes is 17, so the largest number the quota can be is 17, right? Does that make sense? Because you can't go above 17, but it could be 17. You could require that everybody just say yes. Like all of the votes have to say yes. That's called unanimous decision, right? All right. Part C, what is the value of the quota if at least 2/3 of the votes are required to pass a motion? Okay, so 2/3. If that sounds familiar, that's because the 2/3 is if we in the United States, if we want to amend the Constitution, the vote has to pass by 2/3 to do that. Like regular bills, regular like laws that go through the Congress, they only need a simple majority. But if you want to amend the Constitution, you got to have 2/3 of the people that are voting agree to that. So 2/3 is I think it's a pretty common because it's significantly more than 1/2, but it's not approaching unanimous, right? You can have some dissent, but 2/3 is a pretty big portion. So for this voting system, what would the quota have to be if we want 2/3? Okay, so we have to find how many votes is 2/3 of the total number of votes. So if you want to find what 2/3 of 17 is, just like we did 1/2 times 17, you're going to do 2/3 times 17, right? So that multiplication kind of finds the proportion or the portion. All right, so I'm going to clear here. So I'm going to do 2/3, so 2 divided by 3. Notice, look at what the decimal is of 2/3. So 2/3 is 0.666 repeating forever, right? The calculator has to stop it at some point, so it rounds that last digit up. But we don't want to use any kind of approximated value for 2/3. Like you don't want to say, well, 2/3 is about 0.66 and then do 0.66 times 17. You don't want to do that, right? Now, maybe in this case, this might actually work, but depending on like what kind, because we're going to be rounding anyway, but a lot of try to avoid that. Don't use approximations unless you, number one, know that they're going to be okay, or, someone says use approximation. Wait, let me clear. So what we want to do is 2 divided by 3, so that's 2/3, then times 17. So 2/3 times 17. So that's 11.3 repeating. If you remember, 0.3 repeating is actually 1/3. So 11.3, where the 3's continue on forever, is the same thing as 11 and 1/3. That's really ugly. If you remember, if you put the bar over the 3, that's a way to note that the 3 is actually repeating forever. Or you could write it as a mixed number, 11 and 1/3. So it's a third more than 11. So it's a little bit more than 11. So 2/3 of 17 is a little bit more than 11. So then which quota, remember the quota has to be a whole number. We can't put a fraction in there. So which quota? You can't round down to 11 because 11 is not fully 2/3 of 17. So you'd have to round up, right? So in order to get 2/3, at least you'd have to have 12. So we're going to round up to 12. So does that make sense? So you can't use 11 because 11 doesn't actually meet the quota. 11 is not 2/3 of 17. Now, while 12 is a little bit more than that, it is at least that, right? So, and this is happening because we can't use fractions, right? So 12 is the smallest number we can have, right? That will give us at least 2/3 of the vote. So the quota would have to be 12 in order for the at least 2/3 of the votes to be required. Okay, hopefully that made sense. All right. So now we've got a lot of vocabulary under our belt. We know about the weights and the players and the quotas. So let's see if we can answer this question. I'm just going to put it to the top of the screen to give me room, but we'll do this in a separate video here. Okay. In a committee, there are 4 representatives from the management and 3 representatives from the workers' union. Okay, so 4 management people and 3 union people. All right, so for a proposal to pass, 4 of the members must support it, including at least 1 member of the union. Find a voting system that can represent this situation. Okay, so let's make sure we know what we got here. We've got what? 7 players, right? 4 management and 3 unions. So let's write that down. We got 7 players. Wait, this looks so. Trying to get a weight of ink that I like, but okay, we got 7 players. They want us to find the voting system. Okay, so we want to be able to write something down that looks like this. We're gonna give a quota, and then we're gonna give the weight. So there's weight 1, weight 2, weight 3, weight 4, weight 5, weight 6, and weight 7. So our system is going to look like that, with a number for Q and numbers for all these W's. Now I want to, let's see, let's call the first 4 players the management, and these last 3 the union. It doesn't have to be that way. I'm just saying let's call that, right? So let's call the first 4 players, those are the management people. And then the last 3, those are the union people. Okay. So players 1, 2, 3, 4 are the management votes. Whoop. And players 5, 6, 7 are the union. Okay. So we want a system where 4 people voting can pass it, but you can't, management alone cannot pass it. Right? So that idea disqualifies this. Like, so you might think, well, let's just give everybody 1 vote, right? So 1, 1, 1, 1, 1, 1, 1, right? And then that's 7, 1, 2, 3, 4, 5. Yep. And then make the quota 4, right? Because then 4 people, right? That would be, if you have 4 votes, you got 4 people, you got it. However, this does not work because notice that the management can, if they all vote yes, they don't need any of the players, any of the union players to vote, which is a requirement here, right? So it only takes 4 members to pass, but 1 of them has to be from the union. So how can we adjust this system to reflect those requirements? Now, one of the things I thought was, well, why can't we just make the quota 5? Right? Just change the quota to 5. And so that would technically, that would work for the including at least 1 member, right? Because even if all the management voted yes, those would be 4 yes votes, but that doesn't meet the quota. So you'd have to have 1 of the union members also vote to meet that quota. Now, so this sounds good, but it actually violates, or not really violates, but negates this requirement, right? Like, we want to make it so only 4 people have to say yes, right? In this voting system, if we make the quota 5, in that voting system, 5 people have to say yes. So it's ridiculous to have that number 4 be in there if we have to have 5 in order to reach it. So this system won't work because of that, because it doesn't make it so that only 4 members can say yes to vote to make the proposal pass. So we can't use that one. Okay, so not that. And if you play around with this a little bit, you will see that any voting system where all the players have the same number of votes will run you into the same problem, right? Even if you give everybody 2 votes or everybody 3 votes, if all the management and the union have the same number of votes each, then you won't be able to make it so that you have to include one of the union members, but only 4 people are required to pass. So you can't, that's not going to work. However, if you think about it enough, and I don't want to bore you with all of my personal thinking, but if you play around with numbers, which I did for quite a while, play around with numbers, you can see that because you have 4, so you have 4 people in the management position, right? So those are, I'm going to call them M, those are management people. And then you've got 3 union people. What will work here is if the management as a group and the union as a group, if those groups have the same weight. So that is one consideration. Like if you give them each the same weight, right, then you could say, okay, then all of the management together has the same number of votes than all of the union together. And then just make the quota more than that, right? Would you have to anyway, because that would be half and half if they each had the same. So let's try the smallest possible option here, right? So we have 4 people together, they need to have the same number of votes as 3 people. So what we really need is a number that's both a multiple of 4 and 3. So the smallest number that's both a multiple of 4 and 3 is 12, right? So if we can give, so if these people can have, so the management together can have 12 votes and the union together can have 12 votes, we should be able to make a quota such that only 4 members can vote yes and it will pass, but one of them must be a union member. So let's see, we want to divide 12 votes into 4 people. That's going to be 3 each. So that would be each member of management gets 3 votes. And then we want to divide 12 votes by 3 people. So that would be each member of the union gets 4 votes. All right, so now all the management together, if they all vote yes, that's 12 yes votes. But if all the union together, if they all vote yes, that's 12 yes votes, right? So let's just make the quota 1 more than 12. All right, first of all, we have to do that because you can't have the quota be less than 50% anyway, right? But let's see, does this quota work? Can 4 people alone pass it? And is it necessary that one of them has to be a union member? Let's see. Let's take a look. So notice how if all of the management say yes, that's only 12 votes. So they can't meet quota with just them. So if the union member votes, then bam, they're above quota, then they can say yes. Okay. And so notice that is 5 people, right? So 5 people had to say yes in order for that to work. But we actually can get a yes vote with only 4 people, right? So if 3 of the management say yes, that's 3, 6, 9, right? And then if you add 1 union vote, that's 13, right? Because 9 plus 4 is 13. So here you've got a situation where you have exactly 4 people voting. So that's the minimum number of yes votes you have to have, right? But those 4 yes votes actually meet the quota. Does that make sense? And you could even do further ones, like what happens if all the unions say yes, right? They don't meet quota themselves either. But if one manager says yes, then that meets quota and they can pass on that, right? So in whatever situation, you have to have at least 4 people vote yes. And no matter what combination of management and union, one of those people has to be union in this situation. So I think that's a little bit tricky, but it is a really nice exercise to start thinking about if you understand what the quota means and all this kind of stuff. Just a note, if you're wondering, not all multiples of 12 will work here. Because it has to be, if you play around with it, you'll see that like some numbers like 36 doesn't work because you can't divide half of 36, which is 18, into 4. So you couldn't use 36, but you could use 72 if you wanted. So just be aware of that. But 24 works just fine. Like we have 24 votes altogether here. You see that? So the total number of votes is 24. But each kind of voter, the management, the union, together, they each, those subgroups have 12 each. So, and then of course, 13 is more than half of 24. Alrighty, so that is the introduction to weighted voting. In the next video, we will talk about power. Alrighty.